I'll give an overview of different pumps that are common and how to install the motor and get the pump set up in the boat. So the way the pump works, I have one kind of disassembled here. You have a pump housing where water will come in the bottom, be drawn through that center hole, and then discharged out the outlet. And then this is what the impeller looks like. So it's a basic centrifugal pump. Sort of spins, you know, like a hurricane would. These parts are from Battler's Connection. They're the kind of best pump out there that's available. The blue pump base in the back there, that's the old Battler's Connection style. This pump, the blue one, works fine, but the tolerances in the black one are tighter, which allows the pump to build up more pressure and pump more water. So one thing you'll have to decide is what pump motor to use. So these motors here are all brushed or direct current motors. These motors here are brushless motors, which are basically like a three-phase AC motor. So there's different characteristics of each. The brushed motors are very reliable. They're simple to turn on or turn off. You just supply power directly to them and they turn. The brushless motors will need electronic speed control because it's converting direct current into three-phase AC current. So the brushless setup in general is going to be more expensive than the brushed setup. From a pump capacity standpoint, each of these brush motors will pump about the same, around 2 to 2.5 gallons per minute. The brushless motors here can pump up to about 3.5 or 4 gallons per minute, but that comes at a significant increase in the current draw from your batteries. The kind of sweet spot is just around 3 gallons per minute. Above that rate with one of these brushless pump motors, the current goes up a lot for a much smaller increase in flow rate. So when you're starting out, I'd recommend stick with a brushed pump. They're pretty simple and reliable. Pump something that needs to work on the boat, because if you lose your pump, the boat's going to sink no matter how much damage it has. And then once you get more comfortable with the electronics, you can move to a brushed motor a brushless motor. You'll need to get the motor to be, I guess, consistent with your battery voltage. So this motor right here, it's a Traxxas Stinger motor. This is like a standard motor that I'd recommend for a 6-volt setup or like a 7-volt setup. Kind of same thing with this motor. That's a Johnson 600 you get from BC. That's also good at about 6 or 7 volts. This motor is it's a 545, so this is actually configured for like a 20-volt setup. But what you're looking for in a brushed pump motor is a no-load RPM around 15 to 20,000 and kind of the highest power output that you can find. So the Stinger will draw about 25 amps or so if it's kind of going at full capacity. And for comparison, if you go up to 20 volts, this pump will pump pretty much the same capacity at only 3 amps because of the increased voltage. The brushless motors I use, it's a Turnigy 2350 kV motor. The kV number is a ratio to the RPM, or between the RPM and the voltage. So a higher number, motor will spin faster for a given voltage. This motor here is a NTM prop drive 1200 kV, so this is what I'm going to use for a 20 volt pump. This pump right here I run at 13 volts, and it'll pump about 3.5 gallons per minute, but that comes at a current draw of about 40 amps. So for my 12 volt or 13 volt boats, I've been shifting to 1800 kV motors of the NTM prop drive type, which gives a happier balance of about 3 gallons per minute at 25 amps at 13 volts. So I'll show briefly how to assemble the pump. When you get the pump from BC, it won't have this screen on it, but I add the screen just as an extra layer of protection, because you don't want debris to go through the holes and clog the pump outlet. So what I'll do is, this motor has a bad bearing, so I'm gonna disassemble this pump and then put this motor on. So one thing you have to do on the motors, most of them will come with a completely round shaft. I'll use a Dremel and then grind a flat spot, because the pump impeller has a set screw that I have an Allen key attached to. So the set screw will sit on the flat spot of the motor to prevent rotation. I have the pump disassembled, and you can see the flat spot on that motor shaft. One thing I like about this motor is it has a 4mm shaft, which gives more area for the impeller set screw to bite into relative to the 1/8 inch shaft on this motor. So to figure out where to do the flat spot, I'll hold the motor up, and you can see the Sharpie marker there, Sharpie mark on the shaft, so I know where I need to grind it. And then I'll just use a Dremel with a cutoff wheel to make a flat spot on the end there. One modification you'll want to make to the motor plate here is to drill a hole like that, at that angle there. So what that hole is going to do is it'll allow air or vapor to escape from the pump cavity. So what will happen with these pumps is, when they're spinning, when there's water, they'll be fine and they'll continue to pump, but once they kind of pump dry, you'll get this condition called vapor lock, where the pump will keep spinning and you'll get kind of an air pocket stuck in the cavity there. And that air pocket, if it can't escape, will prevent water from refilling the pump and being pumped out. So to prevent that, there'll be holes in the cavity. So you see there's a hole in that plug right there. But if you think about it from a geometry perspective, having a hole at the very top, so specifically, through the side there of the motor plate, will allow all the air to escape, where the hole at this elevation might not allow all the air to escape at the very top. Another thing that this hole does, you can kind of see with the gunk there, is I'll use that to inject corrosion inhibitor to get to the bearing on the brushless motor here. That's a ball bearing which will rust out and fail. There's one at either end. The one at this end you can get to, because that web pattern there, you can just stick the tube in right at the base of it and get it. But this one is more difficult, so by having that hole after each battle, what I'll do is I'll use a corrosion inhibitor to kind of go in that space and keep the lower motor bearing lubricated so it doesn't rust. For a brush pump, you'd have to make 2 holes. So you'd make one that goes into this web area, because you see how the motor kind of seals that whole area, and then I'll do like one through the side there, which will pretty much allow the any vapor to escape. The flat spot here is done. So one thing you want to make sure is to try to make sure the profile is uniform and isn't deeper in some areas than others. Like this one isn't quite perfect, but if the flat spot is slanted, as you tighten it down, the impeller will shift, based off the slant, which can mess it up. So you just want to make sure that the flat spot is, I guess, level or uniform. So I'll probably touch this one up a little bit. I'll show here a few of the different options for controlling the pump, so turning it on and off. So if you have a brushed pump, so kind of a standard thing, a lot of people use a relay like this. So this is a 40 amp automotive relay. You have the kind of main power connections, and then you have the coil connection. So to actuate the relay, you need another switch. So this right here, it's like a Pulolu switch. This switch is rated to like 10 amps or so. I think I honestly probably wouldn't put 10 amps through it, but that's what it's rated for. So for the pump, you need, if it draws 25 amps, you're going to want something that's rated higher than that. So the 40 amp relay is pretty common. So, and then you would just kind of connect these two together. You'd have a power source. This would plug into your radio, and then could actuate the relay to turn the pump on and off. Another option are a couple things from Battler's Connection. So this right here is a just a pump switch, simple in and out. Hooks directly up to the radio, so this is pretty simple. And then the final kind of main option for a brushed pump is an integrated control board from Battler's Connection. So this board right here, we'd call it like an all-in-one board. It has power inputs and outputs, so you plug your battery in, and then you have a direct power feed to go to the speed control for the drive motor, and then one of these connections also could be used for the pump, kind of the same as this. It's just integrated. And then these smaller connections are for the guns. In terms of rough prices, I think this is currently $55 maybe. The pump switch alone is maybe $20 or so. The Pulolu switch, I think that's about $5 to $7, and then the relay is the same. So this is, probably, I don't know, $10 to $15 depending on where you get it combined. The advantage of this board over this board is that this one also has the gun controls. So If you have different gun controls, maybe use this one, but if you're going to go with BC's stuff, I would recommend the integrated board. For a brushless pump, like I mentioned before, you need a speed controller. So this is I think a 60 amp speed controller, got from Hobby King. You got the power in, which is DC, and then you have your 3 phases out, which hook up to the motor. I think this is it's a 60 amp ESC. You can check Hobby King for the latest prices. Probably about $30 if I had to guess, 25 to 30. So it's kind of a general rule of thumb that you want your, whatever instrument or whatever, component you're using to turn the pump on and off, you want it to be rated higher than the expected current draw from the pump. And you can see how I have these waterproofed. Just they're all kind of in bricks of epoxy, which seals them up pretty good. I'll cover pump mounts quickly because I'm going to put them in this boat right now. Actually already started. So with the brushless motor, this outer part spins. So if it's sitting in water, it'll actually create like a vortex around the pump if you have a lot of water, and that can actually like push the water away from the pump so you don't get a suction. So to do that, to address that, I printed up a little shield that snaps on, the little like snap connectors. Okay, so it's snapped on. So the pump mount that I use, that style, is actually really easy. So in this shield, you can see those 2 holes. So the way I mount the pump is I just put 2 posts through the bottom of the hull, and then the pump just kind of slides down on top of those. Kind of like that. And the outlet hose kind of pushes down like that, and that force holds the pump in place. So what's important for a mount is you need to be able to pull the pump off pretty easily. These nylon sleeves will be glued on so they won't come off, but between every sortie, so you see there's like a screen here, so this is to keep debris out of the pump, which will prevent clogging the outlet. So between every sortie, you'll want to be able to remove the pump, clean the gunk off the screen, and then put it back without disassembling anything. Kind of the easier the better. And if you watch my video on the deck, you saw me put in the outlet tube here. So my pump outlet just kind of slides in there on the underside. So this pump is for a different boat, so the hose is too long, but it'll end up being like something like that from a hose perspective. So put posts through the boat. I line the pump where I want it. I actually mark with a marker where the holes should be, and just drill through. On the bottom, I countersink them so they'll sit in nice and flush. So to install these, I'll just fiberglass them. I'll just back these off a little bit, put epoxy on there, screw them in, and then I'll put a nut and washer at the bottom, and then I'll put the sleeve on top. And then I'll put the pump on because these can wiggle a little bit. I'll put the pump to make sure they dry in the right position. Another thing you'll have to set up is the outlet restrictor, which is this guy right here. So the rules say that the pump output needs to be restricted through a 1/8 inch diameter hole. You can kind of see it there. The reason for that is to kind of keep everything kind of a level playing field. So here's what one of the restrictors looks like. To get kind of the optimal configuration, you'll want to make it like a venturi, where it's kind of like a cone on the inlet and the outlet. The steeper cone will be on the inlet, and a more tapered one will be on the outlet. This one I made by using an aluminum rod and machining it on a lathe, and then I think I glued it in the tube here. Alternatively, you can just buy one from Battle Connection. So this is the 1/8 inch. Like this one, that's for one full unit. This one's a 3/32 inch diameter, and that's for a half unit. And then they come, I think it came like this from BC, so you can see it's kind of tapered on both sides. If you get one that's only tapered on one side, you can use like a countersink or something and just hit the other side with the drill, and it'll be good enough. So another thing you want to do is have the restrictor kind of in the middle of the tube. So this piece of tube right here helps the flow be more efficient through the nozzle, so you get a higher flow rate. If I took this tube off, the flow rate would go down by like 20%, which is kind of crazy. The tube here is 3/8 inch outer diameter, 1/4 inch inner diameter, and then the restrictors just fit in there. I used hose clamps on these because it's for a brushless base, where if you don't use them, the tube can fly off. On my brushed pumps, I don't always use the hose clamps, but it is a kind of common problem that if the hose isn't on the base that well, that it'll fly off if there's too much pressure, or maybe if it's hot out, like the middle of the summer, the tube will kind of lose some of its structural integrity and can fly off. So to prevent that, you can see I put a larger diameter sleeve there, which sort of allows that kind of gives you a ridge that you can put the hose around, and then put the hose clamp on that, and you can see kind of the same here. This setup's been effective for me. I haven't had this setup fail at all. I need to figure out how long to make the outlet tube to fit the restrictor. So if you watch the deck videos, I use these tubes here to route the pump outlet out of the hull. So what I've done is I fed the tube in there. You can't really see it, and then I'll just kind of hold the pump, roughly where it goes. And I wanna make sure that the tube is going to be clear of all my sort of internal components. So, looking out for the where the drive shaft is going to come out right there, and then also interference with the accumulation tank there. So this should be pretty good. So what I'll do is I'll plan to get the tube so the outlet is kind of right at the base of this tube on the inside, because the rules state you need to be able to measure the diameter of the pump outlet from external from the ship. So the way I accomplished that, just lost a clamp, is you can put a tube, a 1/8 inch diameter rod straight through there, and then the outlet will be kind of right on the inside, right about here. And what that'll do is it'll allow the rod to go through, so it's legal. I made the mark right at the inside tube there. You can see it. So kind of right where the hose entered. So I'll plan to put the pump, I'll probably maybe add like an 1/8 of an inch onto it, but then I'll probably plan to put the restrictor just about here, and then I'll use a separate tube to go on the outlet, because it's or to force the outlet restrictor into the tube. Before I clamp the main tube down, I put an outlet piece on, so I'm going to feed that through and just make sure that the length on this main portion of the tube is appropriate. So I'll hold this kind of in the representative place, and then you can kind of see the angle there. And it looks like the main tube is sort of right in the correct position. And you can see how it's aligned with the tube through the deck. So that'll make sure you can access it from outside the hull. So I'll probably clamp this one down, and then I'll push this one on a bit further so it's kind of set, and then I'll trim the end there to size. I have this just about set. I trimmed this end piece. You want to make sure that the end of the tube is visible here, because sometimes maybe if you take the pump out, you might forget to route it through the tube again. I've done that before. And if you have it visible, then if it's missing, you can kind of check it when you're setting the boat up. You can see the clamp there. Doesn't look like it'll get in the way. And then I can hold the pump in its position. And you can see there's no major kinks, which is good for the flow, not restricting the flow rate. What I'm showing here is how to balance the pump impeller. So because of the set screw hole there in the set screw, the impeller isn't perfectly balanced about its axis. So what you can do if you want it to be balanced is set up a jig like this, just kind of 2 razor blades and then a shaft. So you can see the effect here of it not being balanced. See how it's kind of rotating back and forth. So to balance it, what you do is you'd let it settle out, and then you'd slowly remove material from that side of the impeller, and then repeat the process until the impeller doesn't settle in the same location each time. This is certainly more of a best practice than required. I've run plenty of pumps without doing this, but it should prolong your motor life slightly if you're facing motor bearing failures. I dremeled out a bit of the webbing around the silver mark, which is where the set screw is, which was the heaviest end. So you can see now it's settling in a different place. But as I rotate it, it doesn't have as much tendency to roll to the same location. So since it's settled in a different location, and I can get it to stabilize in a few different rotation orientations, I think that's about good. So now I'll install it on the motor. To install the impeller, I'll use a few pieces of paper here to set the distance between the impeller, the top of the impeller here, and the bottom of the motor plate. I do that so there's kind of adequate gap so the impeller doesn't rub on the motor plate, and then also so it doesn't rub on the inside of the housing. I use Loctite for the set screw because this is a brushless pump. On my brush pumps I don't use Loctite, although it's never a bad idea. You want to use the blue because it's removable, so you can remove the impeller if needed, if you need to change out the motor. If you use red, you might not be able to get it undone again in the future, which is something that, being able to disassemble this is something you're going to need to be able to do, because the motors will be the limiting factor and they'll die before the housing gets worn out or anything. When I'm doing this next step, I'll make sure I have the flat spot of the motor shaft aligned to a certain face, because if you have it at like an odd angle, once you put the impeller on there, you won't be able to see what the angle is of the set screw hole relative to the flat spot. So since I have it lined up, I know as long as the set screw's going in perpendicular, that it's going to work out. So this is how I'll set it up with the paper, using two pieces so it's balanced, so you're not trying to put the impeller on cockeyed. So I got it held here with just a little bit of pressure, and then I'll put some Loctite in the hole there, and then I will screw the set screw in, ideally with kind of continuous movement until it gets all the way in, so the Loctite seals appropriately. So once I got it screwed in, I rotated the Allen wrench the long way, and then put a pretty decent torque on the set screw at the end. When it went in, you can feel when it contacts the motor shaft, because it'll sometimes cause the motor to rotate a little bit. So now I'll pull the paper out, and then I'll put it in the pump housing and spin the motor around to make sure that the impeller isn't too far down. With a brushed motor, you won't be able to spin it externally, so just plug it into a battery or something. When you're installing the motor plate, you want to make sure that the O-ring seal is lined up appropriately. You'll notice that the casing's not symmetric, so you can see kind of how the gap worked out there. To make sure the gap is good, you can rotate the motor around or plug it in if it's a brush motor, and if it's squealing at you, there's contact. So to test whether the height is right, put it in, squeeze it down a little bit, and then you just rotate it, and check to make sure there's not a loud rubbing sound. So this looks like it's good, so I'll put the screws in, kind of torque it down, and then at some point you run the motor and just make sure it's not grinding. One important thing to check when you assemble a pump with a brushed motor is that you wired the motor to spin in the correct direction. So you want it to spin like this, sort of like a hurricane. So to test that, I'll just sort of plug it into the battery there and make sure it's going the right way. And if not, then just swap those leads. Another common pump outlet method is to just have it come straight up. So you can see the tube there coming out of Agincourt. Now looking inside, you can see the pump. So the advantages of this design, you can see there's kind of like a 90-degree angle right at the outlet. What that helps do is prevent the pump from becoming vapor locked. But it comes at a cost in that the 90-degree angle does provide more flow resistance than a straight pipe would. You can see in the outboards here, I previously had a different pump set up where the pump would just kind of slide into this like U shape. You can see there. I actually have two of them. You can see the two of them there. And then I had, because I got the two pump outlets, so I had two pumps, or a pump and a half, and their hoses kind of crossed. So this type of mount is what I used in a lot of boats before I shift over to the brushless pumps with the two posts. Another disadvantage to a vertical tube is, depending on the nature of the pump stream, if it's a pump that shoots with a decent amount of velocity, it'll tend to roll the boat one way or the other, which can certainly hurt with damage control. So you just want to take that in consideration if you're going to go for a vertical mount. If you have an outlet that's more like, we call it a glug-glug, but it's more like a dribble, I guess, that doesn't cause much downward force on the boat, but like this pump, for instance, will shoot pretty high and it'll roll the boat, which is a downside. I have the wiring harness done and everything hooked up and powered on, so it's good to just do a bench functional test. Test the pump. Spin in the right way. This video covered installing the pump for an RC battleship. Getting the pump functional is one of the most important aspects, because if the pump doesn't work, the boat will sink. Here's a final video showing one of my pumps running in Congo. You can see the massive stream, which is keeping the boat afloat with a relatively large hole cut into the side of it. Thanks for watching. Hope this was useful.